What the country don't want is that we have a very high surge of patients coming into the hospital, right? And what we are seeing here, this is what they want, because the resources that we can afford to be utilized is only this much. So today is March 20th and our third day or restricted movement order. And as usual, during the first day, I mentioned about the impact of COVID-19 and how the virus spreads, and also yesterday about delay tolerant network, how it relates to using the concept of virus for routing purposes. And today I will share with something slightly different, where we have heard a lot about flattening the COVID-19 curve. And in fact, it is the same theory as what we have in telecommunications, which is about queuing theory. Okay, I think some of us have been, a lot of times we didn't realize that we had been in queue, and why suddenly you can find that our queue are so horrendous and very bad. It is because of this queuing theory that I will show with you. And it's the same thing what's happening in the COVID-19, when a lot of people are now queuing at the hospital, and why a lot of healthcare resources have been, around the world collapsed because they are unable to take care of the patients. Okay, let's take a look at what's happening now in the world. So as you see here, the graph tells you about flattening the curve. What the country don't want is that we have a very high surge of patients coming into the hospital, right? And what we are seeing here, this is what they want, because the resources that we can afford to be utilized is only this much. So whenever they are unable to handle it, and unfortunately because the ICU resources is only limited, and if they are unable to get ICU, enter the ICU, this is what mortality rate will happen. So as much as possible, they would like to reduce the number of people coming into the hospital. So let's take a look at this. This is what queuing theory is all about. Queuing theory is where you will see that, this is the transmission system, and when the packets come into the system, they will need to buffer to a memory, and before it's being served by a multiplexer. So this multiplexer have the capability to handle different packets depending how fast the processor going to be. So the MM1 means that person arrival M, person service with one server. So the GGN means they might have multiple servers or multiple multiplexer. Okay, so the way that the data that comes in is in different forms. Sometimes in a person arrival, sometimes just like voice is a person probably statistical model, it comes in, but certain data is deterministic. They come in every few seconds. You know that it will come in at every 10 seconds or every 15 seconds. But certain data comes in bursts. For example, video traffic. At one time, the traffic will be very flat. There is no much data. When there is a certain change of the scene, there's a big amount burst of data. So that's what happened. If the server is unable to handle the nature of the traffic, it will. What happens is that this buffer will only can accommodate certain amount of packet. So for example, like this. So you see this graph. For example, this graph, the blue one shows the MM1 queuing method, where it's only one server. So you can see by when it reaches 80% or 90% of the load, the delay suddenly shoots up because it will not able to handle the kind of traffic. So the rate one shows that you have two server. The moment you have two server, you queue one queue, but there are two servers. So for example, in the bank, you might have one queue, but you might have two counters open. So that will serve better. So the queuing will be less. Okay, instead of one queue, only one counter open. So in this case, the blue one shows the MM1, the red one shows the deterministic, MD1 it shows. So MD1 means that the server is very deterministic. So it serves every 10 seconds. But it's quite impossible. Sometimes the packet is too long, sometimes the packet is too big. You cannot serve that. So the same thing happens in COVID-19. The way that people comes in, the patients that comes in to the hospital, at the moment we are receiving about 100 over patients. And if the resources are, we have enough resources, means that enough server, you are able to cater all the patients. But if the patient comes in such manner, so we don't want to happen suddenly there is amount like yesterday is only 110, and today we don't want that to surge by 200 and then suddenly become 400, 1000. That's what happened in queuing theory. Once we have this surge, the buffer is only limited. The number of beds is also limited. It's the same thing. So the packets that inside the telecommunication system will have to queue. So in this graph, it shows that the queue can be infinite. It's because the buffer is infinite. But what's the case if you have limited buffer? So meaning to say that you only have 1000 packets can be stored inside the buffer. The moment it reaches 1001 packet, that packet will have to be discarded. So the same thing like this. Once you have this is the limited resources that we have in the hospitals. So we don't want that big surge of packet, or in this case the patients of COVID-19 coming in. It will fully utilize the server, and what happened? You are unable to serve the people, and they have to be out of the ICU. And unfortunately, that's what happened in Italy. They have to make a choice whether to allow the older people in the ICU or the younger ones who have more chances to survive. So guys, you have to be very careful when the government mentioned about the restricted movement order. We don't want that kind of surge that comes into the hospital, because the traffic will have very high surge. You only have a limited amount of resources, okay? Because there are other ICU patients, not only the COVID-19, but there are other ICU patients who already been there, and we don't have that enough resources. So that's why the countries are now mobilizing all the healthcare resources in all states. So they cannot have one only in Sungai Buloh. So once they have these resources, hospitals, of the quarantine places, ICU places in different states, you have different kind of server. So the MM1 doesn't exist anymore. That's why this concept, as I mentioned to you just now. So when you have two server, means you have two hospitals or two beds or two doctors, doesn't matter. The server means whoever serves the patients. So you can reduce that. So the more amount of resources, the MM1 means one resource, but MMN can be many resources. You can reduce the delay here, so you can serve a lot of patients. But unfortunately, is that how long can we the patients can recover? So we have seen only 60. How many numbers? I'm not sure. Today, maybe 60 people have already been discharged. So it's very slow. Since the day that we have started to get people coming into the hospital, only a few people have been discharged. So that's the number of service time. So meaning that people, how fast they recover. If the faster that they recover, is that the faster the lower delay that we can have. People queuing to get their healthcare. Okay.